Hello everyone. Today I shall discuss about area of a trapezium. We know that area of a trapezium, the formula of area of a trapezium is half is 1 by 2 into a plus b into h. That is the area of a trapezium. 1 by 2 into a plus b into h. A plus b are the two parallel sides and h is the height of the trapezium, right? Now this is the area of the trapezium. Now you shall find area of a general quadrilateral. Here you see area of this quadrilateral ABCD. This can be divided into two triangles, that is ABC and ADC. Therefore, we will add this area of triangle ABC plus area of triangle ADC. The area of this triangle is half base into height, that is half into AC into H1 plus half AC into H2, right? Therefore, half AC into H1 plus H2, that is equal to 1 by 2. AC is diagonal, right? D into H1 plus H2, where D denotes the length of the diagonal. In this way, you can find the area of this quadrilateral, that is half D. D means diameter into H1 plus H2. Right? In this way, you can find the area of this quadrilateral ABCD. Here you see, find the area of the quadrilateral PQRS as shown in the figure. This is PQRS, PQRS. So the formula is half D into H1 plus F2. Half, this diagonal is 5.5. H1 is 2.5 and H2 is 1.5. If we add this one, we are getting the value as 11 centimeter square. In this way, you can find the various areas of quadrilaterals by this formula. Area of special quadrilaterals. We can use the same method of splitting into triangles, which is called triangulation, to find a formula for the area of a rhombus. In figure 11.13, ABCD is a rhombus. Therefore, its diagonals are perpendicular bisectors of each other. That is figure 11.13. This is 11.13, right? Therefore, area of the rhombus ABCD is equal to area of ACD, area of ACD plus area of ABC, right? Now half, this is half into AC into OD plus half into AC into OB, or you can say half AC into OD plus OB. That is, we are getting half AC. AC is D1 and OD plus OB is BD. That is half into D1 into D2. In other words, area of a rhombus is half the product of its diagonals. That is, half the product of its diagonal, half into D1 into D2, right? That means area of a rhombus is half the product of its diagonals. Now, this is the next question is, find the area of a rhombus whose diagonals are of length 10 cm and 8.2 cm. Therefore, area of the rhombus equal to 1 by 2 into D1, D2, where D1, D2 are the lengths of diagonals. Therefore, we are getting 1 by 2 into 10 into 8.5 cm square, that is 41 cm square. A parallelogram is divided into two congruent triangles by drawing a diagonal across it. Can you divide a trapezium into two congruent triangles? Here you see, you find the area of a parallelogram. We split a quadrilateral into triangles and find its area. Similar methods can be used to find the area of a polygon. Observe the following for a pentagon. Here you see, there are 1, 2, 3 triangles. We will find the area and add it, and we will get the area of this figure. You also see there are 1, 2, 3, 4, 5 figures. 1, 2, 3, 4 are triangles. 1, 2, 3 are triangles. And this is a trapezium. And if we add all the areas, then we will get the area of this figure, right? In this way, you can find the various areas. Here you see this one. Here you see there are 1, 2, 3 triangles and 1 trapezium. And we find the area of each and add it, and we'll get the area of this figure. In the same way, this figure can be also found out, right? Because there are 1, 2, 1, 2, 3, 1 triangle, right? In this, you divide this into various figures of geometrical figures and add it, the area of each, you will get the area of this figure also, right? You know that area of a trapezium will half h into a plus b. A and b are the length of parallel sides, right? In this way you can find here also, right? In this way you can find the various geometrical figures. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.